Welcome to week number 8, Math 150 at Franklin. We have our test number 2 this week. So I'm making a video so that people can review the week number 8 ALEKS homework whenever is convenient as you coordinate that with your reviewing and studying for test number 2. Week 8 is all about functions and relationships and learning new notation. If you're heading into college algebra, it is imperative that these notations make sense. If this is your last math class ever, you need to learn them and understand them. It will create neural pathways and make your brain smarter, even if you don't use these notations much beyond test number 3 and our final. All right. Here's the notes you can download. You can take a screenshot. Here's the key notation that's new. And the bottom line is f of x is a notation for y. So everything you've already learned about linear equations and everything we'll learn about quadratic equations will hold true. It's just now instead of saying y equals mx plus b, we can say f of x equals mx plus b. It means the same thing. It's a notation that gives us more flexibility and actually becomes more useful than just the generic y. We have our x coordinate, and now instead of calling this a y-axis, we call it an f of x axis. If you're seeing this function notation for the first time, I like to explain that we've convinced you up to this point whenever two letters next to each other, it's multiplication. But in this case, it's not. This is a function with the very non-exciting name of f. This function named f takes one variable, and they're telling us that the variable it takes is an x. So this function named f is going to take a variable called x and do something with it and spit it out the other end. You can think of your function as a black box. You can think of your calculator as a function. Your calculator is definitely a function machine. You throw a number in and it does something to it and spits a different number out. So the number you put in is your input. The number coming out is your output. So you'll learn this notation this week. We're only doing sections 8.1, 2, and 3. 8.3 is graphing. Graphing is drawing a picture that shows all of the solutions. And so we've been graphing with x comma y. Well, instead of using y, we're going to show how tightly this xy pair is related to each other. It's now an f of x pair of numbers. It means the same thing as an xy pair of numbers. So we have linear functions. The parent function for that is y equals x. We have absolute value functions, where y equals the absolute value of a number. We have quadratic functions, which we've begun working with already. Oh, I'm sorry, my linear is supposed to be just an x, not an x squared. And then cubic functions, where we have a third degree. The graph of all linear functions will be a straight line. The graph of all quadratic functions is a parabola. The graph of absolute value functions, it looks like a line in part, but the negative values become positive. And so we find all of our absolute value functions actually make a V when we graph them. And then our cubic functions, they're degree 3, and they have a squiggle here, and they'll look something in general like that. In future classes, you'll study end behavior, where the arrows are heading off. All right, quick commercial for this Introduction to Polynomials function video that you can watch on YouTube. It is actually very helpful. It will go through a lot of the notation and the vocabulary and things that you know. It's done by Professor Baldwin. Watch at least the first 4 to 5 minutes of this to learn the notations, hieroglyphics, the way things are written. If you want to watch the entire 15 minutes, it will help you as well. All right. So, quick review for the test. Solving these equations, we're using the zero product property to rewrite equations so that we can more easily see the solution. Again, to solve an equation means to find the values that make the equation true. We're always supposed to simplify. So given this equation right here, I first figure out exactly where the equal sign is, because two favorite rules in math: do whatever you want to both sides of an equation. Or my other favorite rule is you can multiply by 1. This case, I don't need that, so I'm going to choose, I've got 2 and 4 in the denominator, so I'm going to choose to multiply both sides by 4. What I've done here is distribute this 4 to each term. Now I can reduce because my numerator is factored. That's why I'm allowed to reduce here. This numerator for my second term is factored, so I can reduce here. So now that I have this 2 distributed to each term, I will have 4v. 7 times 2 is 14. You have creative license to rewrite any equation so long as it has the same value. Simplifying the left side. Now I'm going to do whatever I want. Again, when I'm solving the equation, I'm looking for what makes the equation true. Well, if I can rewrite the equation so it has the exact same value, but it's written in a very basic form, like v equals a number, well, that equation, it's obvious to see the answer. I'm trying to rewrite the original rational polynomial equation that we were given. I'm rewriting it over and over and over until it becomes much more simplified and a simpler equation. 24 minus 17. Dividing both sides by this 7. So this tells me that whatever number makes this equation here true will also make the original equation up here true. So if we want to, we can check. I have 2 times 1 plus 7 over 2, and I add that to 3 times 1 plus 3 over 4. Will that in fact equal 6? When you tell me v equals 1 is a solution, you're telling me that when you substitute the number 1 back into your original equation in place of the variable v, then your original equation will be true. This equation here has the same value as this equation, v equals 1. Well, v equals 1, everybody can tell 1 equals 1. So that's why we stopped there. All right, so checking my work. Again, and Alex, they're not asking you to check your work, but I have 9 halves. 3 plus 3 is 6. That's 6/4. What is that going to equal? When you add or subtract, you need a common denominator, so I'm just going to simplify. I have 12 halves, 12 divided by 2. Yes, indeedy, 6 equals 6. This is a true statement. So yes, the solution to my original rational polynomial equation is when the letter v is replaced by the number 1. Okay, yes, you'll be asked to solve equations on your test. Week 8, this is not on test number 2. Week 8 talks about domain and range. Domain is your input, range is your output. So my domain is here, my range is there. The domain are your allowable x value inputs. Your domain is the x coordinate if we're giving you ordered pairs. The domain is also called the independent variable. The range is all of your y value outputs. the y values, and the range, the output depends on your input. So the range or the y values or the f of x values is considered the dependent variable because it depends on the input. So in order, when this question here is asking, looking at if this is your domain, does each item in your domain map to only one answer in your range? And in this case, it does. So this is a function. Relation 2. Does each of my inputs give me only one output? Yes, in this case it does, except for the number 1. The number 1 is mapped to 7 and it is mapped to 4. So because of this number right there, we say no, that is not a function because it does not have a 1-to-1 correspondence. Pick one number or one value and it has to answer to one output. Here my inputs, my domain are M, B, Y, G. Let's make this a little bigger. Okay. So the elements of my domain is the set of all variables M, B, Y, and G. The elements of my range or output are B and M, and that's it. Is this a function? Well, my recommendation is to, when in doubt, draw it out. I have M, B, Y, and G for my inputs. I have M and B for my outputs, and then M to B maps M to B. B to B maps B to B, so that's okay. Y to M maps Y to M. And G to M maps G to M. So yes, this is a function because each of my variables in the domain, each of my inputs will yield only one output. Again, the problem with relationship 2, this relation 2 over here was the number 1. Sometimes the output would be a 7 and other times the output would be a 4. So that makes it not a function. All right, relation 4. Again, I like visually. I've got my domain, -2, -4, 3, and -5. So these are the elements in my domain. The elements in my range are just one letter, okay? How does this work? -2 input, outputs a B. -4 input, outputs a B again. 3 input, outputs a B. -5 into my function, outputs a B. So this is a function because each input only goes one place. Now, all of the inputs go to that one place, but that's okay. If we're to use our new function notation, my function machine F, if I input the number -2, it outputs a B. If I input a -4, it outputs a B. If I input a 3, it outputs a B. And if I input a -5, it also outputs a B. If I were to graph this on a typical Cartesian coordinate plane, my X inputs and my F of X outputs, that means that -2, I would output a B. I don't know where B is, so I'm going to say that this line right here is B. So input -2, output B. Input -4, output is B. Input a 3, output is B. Input a -5, my output is AB. So I have 4 elements in my domain. I have 4 allowable X values that I can put into my function. 4 elements into my domain, -2, -4, +3, and -5. And I have 3 points. What you'll learn about here as well is a vertical line test. The vertical line test says your relationship is a function if and only if for every vertical line you draw anywhere on the plane, the vertical line will only intersect your function once. Now, yes, I have drawn 4 lines. I could draw 4,000 lines. All of these other lines will not touch any point. But these 4 lines actually do touch my function. They touch in one point. So yes, this is, again, another way to say it is a function. The vertical line test will clear up later with better examples. But I want you to hear the word, and I'm going to write it out, vertical line test. That I thought when I first learned it, I thought that was just some funky shortcut that my teacher was telling me, but no, it's actually a mathematical term and concept that works through calculus and beyond. And here's where we're going to apply it. If I give you a picture, when Alex and I give you a picture and say, state if this is a function or not, you're just going to check with the vertical line test. Graph 1 has only 4 points in my relationship. So yes, this is a function because each vertical line crosses no more than 1 point. I have vertical lines that cross no points, but every vertical line, if it crosses my function, it only crosses in one place. Graph 2 is a no, because I've got places where it crosses twice. Graph 3 is a yes, because for every x value, my line will only cross the graph once. Graph 4 is a no, because I have many places where it fails the vertical line test. And hopefully you've already figured out the last 2. And this one here is a no. And this one here is a no because I've got one right there. If you find one place that it fails, then your relationship is not a function. So again, to do this here is okay. This is a function because the open circle means it's not part of my function. The closed circle means that it is. This one here is not. It's also not because that. This one here is not. This one here is not. Again, you only need to find one place that it fails. And this one, check. Oh, this one's okay. And this one is okay. This one is actually the quadratic. This is the parent function, y equals x squared, a second degree polynomial. All right, now we've got a relation H is defined this way. Draw your picture. Here are your x values. So I just have 4 and -3 in my domain. In my range, I'm going to have the outputs. My range is the outputs. So 4 maps to -1. 4 maps to 4. And right there, I know it's not a function. Okay, so there we go. Not a function. All right. They're asking me now for the domain and range. So my domain, my domain is the set of all numbers, and we usually write them from smallest to largest. We write them in ascending order. The range is -6, -1, and 4. Yes, we put these squiggly brackets because that tells the world this is a set. It's called set notation, like the set builder notation from weeks previous. Okay, again, the domain. The domain is all of the x coordinates. 6, 8, 9. The range is P and the number 0. Done. That's all it's asking for. Write it in set notation, means if you don't have those squiggles in your answer, and in Alex, there will be something down there that has a little box with squiggles, or you can find them on your keyboard near the return key. All right, here's how you use a function. They're saying, here's a machine called G. I have a function called G. G is going to take one variable. It's called an X. So whatever you put into G, here's the rule. Here's the game that my black box called G, this function G, is going to take the number, multiply it by 4, and then add 2. It's going to take the number, add 3, and then it's going to divide those numbers. So there's the definition of what the function is going to do. So it says find G of 5x. So find G of 5x. And you're not multiplying G and 5x. You're plugging 5x into your function. So my function is going to take something, and I'm going to rewrite it on my paper. And I suggest you write it on your paper like this, what I'm doing in purple as well. There's the X, there's the X, there's the X. So whatever gets put in here gets put in there. And then you're back to week 4, I think it was, or 5, where you're rearranging and simplifying your polynomial expressions. So my input is 5x. Here is what my function G is going to do when we give it 5x. It's going to become 2 plus 4 times 5 times x. 4 times 5 is 20, and 3 plus 5x is... Now, after the last few weeks, I hope that you want to factor, and that numerator can be 2 times the quantity 1 plus 10x. My denominator is 3 plus 5x. These are relatively prime. That means these polynomials cannot reduce anymore. So this in the green box is what I would put into Alex, and you're done. That is the output. G of 5x is 2 plus 20x over 3 plus 5x. Done. Here we have a different function of a different color. This function G is going to take x, but it's going to square the x, multiply it by 2, and add 1. So find G of 3x. Well, G of whatever is 2 times that whatever squared plus 1. What am I putting in? I'm putting into the machine 3x. So now look just at this part and simplify. And if you don't get a numerical answer out of your machine, that's okay. Notice rules of operation, this squared applies only to the 3x. So what I'm looking at is 2 times 9x squared plus 1. Order of operations says do this first. 9 times 2 times x squared. So here's my final answer. This is what G of 3x equals. And that would be your answer for Alex. All right, word problems. Yes. But these word problems, we give you the equation. The equation will have 2 variables. And I'm going to tell you what one of the variables is. So here's the equation using function notation. Manuel wants to save $700 to buy a TV. He saves $19 each week. The amount, called capital A in dollars, that he still needs after W, weeks, is given by the following function. That is the amount he still needs, depending on the number of weeks that have already passed, is the same thing as that $700 minus 19 times the number of weeks that have passed. So they're giving us the function. It's true, don't have to ask. A, if Manuel still needs $377, then how many weeks has he been saving? Where students get messed up here is figuring out, is that your A of W? Or is that your A of W? They tell us that W is the number of weeks that have passed. We're asked to find how many weeks, so we don't know the W. That's what we're looking for. So if he still needs 377, so to answer part A, you write 377 equals 700 minus 19W and then solve. There's my equal sign. I can do whatever I want to both sides. When I'm solving an equation, I'm trying to isolate the variable. $377 minus 700. And 377 minus 700 in my calculator, I just typed in 700 minus 377 because I know that the answer has to be negative. If I've got 377 and somebody takes away 700, I know that it's a negative number. 323 divided by 19. In this case, negative 323 divided by negative 19 will give me a negative divided by negative is positive, and my W is 17. Translating that back into the word problem, if he needs $377, he has been saving for 17 weeks. Part B, how much money does he need after 7 weeks? So what part B is telling us, if W is 7, find A of 7. A of 7 is 700 minus 19 times 7. 19 times 7, 133. So 700 minus 133. And that's how much he still needs. Someone needs $567 after 7 weeks of saving. All right, same thing for the next example. The railroad crew can lay 6 miles of track each day. They need to lay 168 miles of track. The length L in the units miles that's left after D, which is in units days, is given by this function. So the number of miles left is going to equal 168 minus 6 times the number of days worked. How many miles of track after 18 days? So my miles of track is the same thing as 168 minus 6 times 18. And then you solve from there. If you prefer, instead of L of D, you can just pick your own variable and say miles. And then for part B, how many days will it lay them to lay all the track? This is a tricky one. And the reason I picked to do this one is if we've laid all the track, if they've laid all the track, then there are 0 miles left to lay. Well, if that's the case, then I have 0 equals 168 minus 6D, and then you solve for D. All right, moving right along. Here's the graph of the function. Finding inputs and outputs. The X values are your inputs. The Y values are your outputs. If H of X equals 0, then the 0 is your output. So if the output is 0, then we know H of -4 is 0. So my X is -4 when my Y is 0. Shorter, easier way to say X is -4 when Y equals 0 is like that. Find H of -2. Find H of -2. It's the same as find your Y if the X is -2. Well, where is my X -2? Here's -2 on the X number line. So here is my point. So I look over here and that would be -1. So H of, make your X -2, and where does it cross that blue line? The Y is -1. So -2, -1 is this point right here. And -4, 0 is this other point. So keeping straight which is the input and which is the output. Keeping straight that H of X is one specific numerical value. H of -2, that means take your -2, go on the X number line and let X equal -2, and then figure out what Y value corresponds with that value for X. Another one here. Yep. If my f of X equals -1, this means if the Y, or I'm sorry, +1, if Y is +1, find the X. For a point on the graph. In this case, there's only one, but I look on my Y number line. When Y equals 1, that's right here. So my X equals 0 because the point 0, 1 is on the graph. It's the only point on the graph where Y equals 1. Now switch, find f of -2. That one's even easier. F of -2, let X equal -2, and find a Y for the point on the graph. on the graph. So I'm on my X number line here. And I find -2. And then I look at X equal -2. Aha, there is the spot right there. So then I see that -2, -1 is on the graph. So now I know that f, I input a -2 into my function, it will output a -1. Just like over here, f of 0 input will give me an output of 1. I'd love to take questions or comments, but it's a video, I'm sorry. Leave it right there if you want a quick screenshot. So in this case, this first case here, they're telling you, hey, the Y output is 1, find the X. In this case over here, they're telling you the X is -2, and so your mission is to find the Y. And that would be this point over here. More quickly, if h of x equals 1, y equals 1 here, so I've got 2 of them. So h of, and then I look down here to see -1, and I look here to see 2. So h of -1 will output 1. And if I input a +2 into my function named h, it will output a 1. Find h of 0. Let's let x be 0. So x is 0 right here. So h, if I input an x value of 0, my output y value is -3. This tells me that -1, 1 is a point on my graph. This tells me that the point 2, 1 is on my graph. And the point 0, -3 is on my graph. So these are 3 points on my graph. And I really want you to connect that h of -1 equals 1 tells the exact same story. It's a synonym to -1, 1. I input the x value of -1, I output the y value of +1. It's right there, -1, 1. There's a relationship between this function and the graph. The graph is all of the xy pairs that make the function true. All right, here it is. Give the domain and the range. The domain is the set of all x's. So I look here, x values, x values, x values, x values. I know this relation is not a function because right here it fails the vertical line test, but my domain is still -2, +4, and 4. The range is I'm looking at all of these points and where they cross the y-axis. So my range is the set of all numbers, and again, we usually go from smallest to biggest in ascending order. And that would be my range. And that's what Alex is looking for. Make sure you use the set notation. Set notation means these funky squiggly brackets. Okay, again, looks like the same problem. It's exactly the same problem. Sorry about that. Domain. So I'm looking here. The domain is I'm looking at this function that goes here. So all of these x values are needed. So my domain is the set of all x values such that x is strictly less than 5, but it's bigger than or equal to my -5. How do I know? This is a closed circle and this is an open circle. So this has to be less than or equal to, and this has to be strictly less than. Now I'm looking for my range. So again, I'm looking at the graph they gave me here, but now I'm looking along the y-axis. So it would be all of these points up to, but not including that point. So my range is the set of all y values. So the set notation, tell the reader what variable you're using, and then put a long line that means such that. The range is y values such that the y has to be strictly less than 4 and greater than or equal to -5. And that's what Alex is looking for. And that's what it means to write the domain and range. Oh, they wanted interval notation. Sorry. It'd be better if I read the directions. The domain is everything from -5 up to, but not including +5. And again, with interval notation, you have to write smallest on the left, biggest on the right. The range is -5 up to, but not including 4. This is what I would put into Alex because I would read the directions before I wrote my answer. Okay. You can pause at any time. This is the entire graph of the function. It looks like part of a quadratic. Okay, the x looks like it goes from here to here. This one's filled in, so my domain in, they wanted an interval notation. So it would be from a -3 up to, but not including 2. And the range is the y direction, and so it would be from here all the way down to and including here. If I had a spotlight shining right, left, where would the shadow fall on the y number line? Well, it would fall on all of the numbers from -5 up to 4, and it would include both endpoints because I have a solid circle point here and a solid there. Yes, this is open, but this here is solid. So when I look at all of these values compared to the y-axis, that's how I'm finding my range. Another domain and range, we're almost done. Again, please watch that other video with the function notation that I told you about. The domain is the x. So I look at this graph in relationship to my x number line. Okay, it is not all real numbers. It's only some of them. So it's not -2, but it's everything close to it. And it's not +2. And they want the output. Okay. My domain is all the numbers from -2 to +2, not including the endpoints. Range is y, it would be from here down to here. It would be -2 up to +3, again, not including the endpoints because the ends of my graph are not included in the function or in the relation. All right, it is a piecewise. So now they want unions or interval, whichever way I have to do it. Okay. Looking for my domain is x. So I'm looking along this x number line. Where do these graphs, if I were to have a spotlight running up and down, where would the x values be? Everything from not quite this up to and including 1. And then it would be an open circle here and a closed circle here, because again, I'm looking at what x values are needed to make all of those points. So my domain An interval notation would be not including -3 as an endpoint up to including 1 as an endpoint. Notice the bracket when it's a solid and parenthesis when it's open. Or I also have open 2 up to closed 5. So there's where I have all of my values for my domain. Now the outputs, if I were to list all of the points that make this relationship here, or this one actually is a function. If I were to have, sorry, my dog is sneezing. All right, so now for the range. Sorry about that. Now for the range, I'm looking in the Y direction. So I pretend there's a shadow or a light going this way. And where will my graph cross the Y axis? Well, it would be an open circle here and all of these points to the closed circle there. Let me erase my scratch work. Get rid of all the domain info. So it would be closed circle here, down to open circle there, and open circle here, down to a closed circle there. Because again, all of these points, what are the possible Y values or outputs? So from smallest to biggest, the range would be -5 up to -1. This is a solid bracket. This is open. So -5 would be a bracket. And -1 would be a parenthesis, because the parenthesis does not include the endpoint. The bracket does include the endpoint. Or I've got from open circle 3 to closed circle 4. +3 to +4, but 4 gets the bracket because that endpoint is included. 3 has a parenthesis. And there you go. And that's what I would put for domain and range. Also, a quick review of interval notation and what the brackets mean. The endpoint is included. The parenthesis means it is not. Always, 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 always write these from least to greatest, smallest number on the left, biggest number on the right when you are writing your interval notation. All right, and I think I've got a few more of those we can do. If you're stuck with that, shoot me an email. I can do some more. Graphing a function in the form f of x equals ax plus b. This is the same thing you've been doing. Y equals mx plus b. Don't be thrown. Graph this function. If you need to rewrite it as y equals 2/3 x plus 3, because that's what your eyes and brain are most familiar with working on, go for it. It means the same thing. Do I have my graph here? I don't. All right, so we're going to sketch a graph. My 0b, I know that 0,3 is 1 point on the line. So there it is. I know that my slope is 2/3. This is good review from week 4. My slope would go down 2 and over 3. Down 2 and over 3. Up 2 and to the left 3. So here is where you would find, those are 1, 2, get my highlighter. 1, 2, 3, 4 specific points on the line. That means my line is going to go through all of them. So here is the line that goes with this function, f of x equals 2/3 x plus 3. There's the function, or you can write it as an equation. And all of the dots on this line that you draw are the xy pairs that make the equation true. So 0,3 is 1. This one over here, 3, 1 is another. Oh my goodness, I can't believe I did that. I just totally messed up on my graphing. If you were freaking out, God bless you, that's great. I am so sorry to freak you out. My bad. Complete brain fart on video. And I'm so far in that I probably won't redo the video here. My apologies. Evidence that your teacher is definitely human. Try this again. If my slope is a positive 2/3, then I run up to an over 3. So again, starting at this point, 0,3 is right there. Slope of 2/3 up 2 and over 3 would put me here. Up 2 more and over 3 would put me here. Down 2 and over 3 would put me here. So again, I've got these 4 points that make the equation true. So the line that contains those 4 points contains all of the XY pairs that make this equation true. So this is the point 3, 5. Six, 7. -3, 1. And these are the points that make this function f of x equals 2/3 times x plus 3. To plug it in and to use this notation, f of 0 equals 2/3 times 0 plus 3. 0 plus 3 is 3. F of 3, picking this point right here, f of 3 would be 2/3 times 3 plus 3. 2/3 times 3 is 2. 2 plus 3 is 5. So that's the point 3, 5. Check right there. Different one, if I pick the point 6, 7, f of 6, if my x value equals 6, then 2/3 times 6 plus 3 . Twelve thirds is 4, so my final answer would be 7. And yes, we are correct. If the x coordinate is 6, the y coordinate is 7, and that gives us another point on the line. Last one to check, f of -3. If my x value is -3, then I have 2/3 times a -3 plus 3, because that is my function that they gave me, 2/3 times the input plus 3. Positive 2/3 times -3, positive times negative is negative. So f of -3 is 1, which is the same thing as -3, 1. Yes. Hopefully this is connecting and solidifying that the graph and the function are telling the same story. They're giving you all of the XY pairs that make the function true. They're giving you all of the XY pairs of numbers that are coordinate points that lie on the line. Graphing a function again with the fractional slope, same idea. Same idea. Graphing an absolute value equation. The parent function for an absolute value is going to be a v. And whether it horizontally or vertically shifts, whether it flips, instead of being open up, it becomes open down. Those are great patterns you can learn to recognize. You'll get into that in college algebra. At this point, graphing the equation, I would pick an x value and plug in to solve for the y value. I like to pick easy numbers, so I'll start off with something like 0, 1, and -1. So, and I'm going to use the function notation. F of 0 is the same thing as the opposite of 0, so that would be 0. F of 1 would be the absolute value 1, and then change the sign. f of -1 is the same thing as the absolute value of -1, and then change the sign. 0, 0, -1, 1, and I know it's a V, so I know it goes off like that. Here are the 3 points that I chose to graph. And away we go. I would also encourage you to use Desmos.com as you're working on these. This function here, -4x² plus 5, its parent function is an x squared, so it will be a parabola. It will either be open up or open down. As you're learning and as you're recognizing these patterns, I suggest Desmos.com to check your work. I know that this is going to be open down because it has a negative. I know that it's going to be a parabola because it has an x squared. And I know that this plus 5 is going to shift it up. So I know that it's going to be something around here, 0, 5, and then it's going to be open down, and I know that it's going to be that general shape. On the test, we give you a graph and say, you find the function that matches with this graph. What I'm testing is, do you understand that the function has to have all of the order pairs that make the equation true? So if my x is 0, then f of 0 is going to be -4 times 0 squared plus 5. 0 plus 5 is 5. So my f of 0 is 5. That means the point 0, 5 is on my graph. If I pick a 1, f of 1, well, then I have -4 times 1 squared plus 5. -4 plus 5, that's going to be 1. So that means somewhere over here, oops, sorry, ahead of myself, this would be the point 1, 1. Because if my input is 1 and my output is 1, that means my x is 1 whenever my y is 1. Now, if I input a -1, then I would have -1 squared. Well, -1 squared is 1. 1 times -4 is -4. So even if I input a -1, my function is going to output a +1. So I know that this point -1, 1 is also a point on the graph. I know the vertex is 0, 5. My line of symmetry is here at x equals 0. All kinds of information you'll need to know in college algebra. All right. Some more of these, graphing these functions. This is an x cubed. Parent function is going to look something like this and something like that. So that's the thought bubble. Pick some points, plug them in, and graph. Here we go. Last bit. Find all of the values that are not in the domain. What is not allowed? So the numbers not allowed. Any number that gives you 0 in the denominator or a negative under the radical. You can fast forward if you're on video. And it's having a hard time. All right, here's my denominator. So what you're going to do is let the denominator equal 0 and solve. Those are the numbers that are not allowed in the domain. You're going to have to factor. Use your zero product property. That's actually a perfect square. 4 times 2 is 8, 4 times 4 is 16. So this is actually x minus 4 times x minus 4. I have factored this. I'm now going to set each factor equal to 0 and solve. Well, x minus 4 is 0 if x equals 4. So x is not allowed to be 4 in my domain. So pick the value. In this case, in every case, it's what makes your denominator equal to 0. So you're going to let your denominator equal to 0 and solve. Let the denominator be 0, then solve for your x. One more exam. So solve for x. Okay, back to review for exam. That's it for week 3. Read the video posted at the beginning of this document, and you can stop there if you need to. I'm going to do a couple more examples here quickly for review for the test. Find your equal sign. Do whatever you want to both sides to get rid of the denominator. In this case, when you have a fraction equals a fraction, and you multiply both sides by your denominators, you're good to go. If you know to cross multiply, that's a cool trick that we teach students before they know algebra. Over here we have more space. Negative 6x minus 18 is the same thing as negative 15x. I need all of the x's on one side, all of the numbers on the other. So I'm going to choose to add 6x to both sides. Notice that that means this negative sign still exists. I want x by itself. What's blocking my goal is negative 9. So I now have 2 is the same thing as x, and there's my solution. Now I need to go back and double check to make sure it will make the equation true. If I have 2 plus 3 in the denominator, that works, it's not 0. If I have 2 in the denominator, that works, it's not 0. You need to go back and make sure that your answer is an allowable answer for the domain. Given this problem here, negative 2 is the same thing as negative 5 over y minus 5. Notice rules with negative hanging out in front of a fraction. You can put it in the numerator or the denominator, but not both. Now I can do whatever I want to both sides. I don't like having the fraction, so I'm going to multiply both sides by y minus 5. So I'll have negative 2y, negative 2 times negative 5 is a positive 10. And the right side just becomes a negative 5 because these factors can reduce. I am now going to subtract 10 from both sides. Again, writing the answers and showing people what's going on and what you're doing makes it better. So divide both sides by -2 and y would be a 7.5. And again, this last one, solving the proportion here. The way cross multiplication works is only when you have a fraction equals a fraction will it rework such that you have 21 times x plus 3 and 30 times x. Only when you have a fraction equals a fraction can you take these opposites. You may have seen teachers do that in the past. I hate teaching cross multiplication because then students use it in inappropriate places when it's not allowed. Here's the reason why it works. I'm multiplying both sides by the same thing. I'm multiplying both sides by x plus 3 times x. That's what I'm really doing. That's why those go away, this goes away. And I'm left with this, which is the same as this. 21. So it's my 21 times x plus 3, 21 times x plus 3. 30 times x is my 30x. And that came from the 21 over x being equal to 30 over x plus 3. So yes, in real life, I want you to be able to go from here to here. I just really want you to understand why, so that you only use it when you're allowed to use it. Simplify each side. Do whatever you want to both sides to get the x on one side and the numbers by itself. Goal is x, multiplying is blocking that goal, so I choose to divide. Final answer, x is 7. All right, any questions or comments? Shoot me an email, let me know. Have a great week.